Okay, hello everybody. Welcome to our second online lecture. So today's date, the 24th of March. Okay, and as a reminder, I will be doing office hours. Every day we have class, Monday, Tuesday, Wednesday, Thursday at 3 o'clock. So if you want to, you just go to Canvas. You go to Canvas, and then there's a WebEx button, and you click on it, and you can join the virtual meeting. Okay. All right. So. Monday, Tuesday, Wednesday, 3:10 through 4. Okay. All right. Okay, so today's topic, we're going to do section 1.6, which is about inequalities. Inequalities. Okay, so inequalities are just like equations we've been working with, except for instead of equal sign, you use inequalities use less than or equal to, greater than or equal to. Okay, so for example, if you have a real number, right, then a real number x then we know that x times x, whether it's positive or negative or 0, equals x squared is always going to be greater than or equal to 0. Okay, so that's one example of an inequality that we kind of know already. Okay, so when working with the inequalities, there's one thing that's very important. You can simplify, combine like terms, and add and subtract terms. Normal. Okay, so, and I'll write this down and I'll get into what I'm saying here with some examples here in a second too. Need to be careful when you're multiplying or dividing. Okay, so the reason is so for example, we already know this simple inequality here that 2 is less than 3. Okay, so if I, for example, add 1 to both sides, which you can do, then we get 3 is less than 4, and the inequality remains true. So adding and subtracting, right, that inequality will the inequality will still remain true. However, if you started with 2 is less than 3, and I multiply both sides by any negative number, okay, which multiplying by any negative number includes dividing by any negative number, because you could, for example, multiply by 1/6, negative 1/6, and that'd be the same thing as dividing by -6. Okay, so just for simplicity here though, let's multiply both sides by -1. So if we were not careful, then we would write -2 is less than -3. Now think about that for a second. So that's not true, because if you look at a number line, you've got 0 here, -1, -2, and -3, and then here we have 1, 2, and 3. So originally, yes, 2 is less than 3. But then when we multiply by -1, now we have a -2 and a -3, and actually -3 is further to the left on the number line. So the way this ordering works is actually that when you do this multiply, you have to flip around your inequality. Okay, so whenever you multiply or divide by -1, you flip the inequality. So I'll write that here. Oops. Or okay. Sorry. Okay. Okay, so let's get to our first example. So we can now talk about linear inequalities. Linear. So remember, linear, when they say linear, they mean like a linear equation right here on this side, or a linear polynomial. Okay, 1 second. Okay, or ax plus b is less than 0. Or you could have less than or equal to or greater than or equal to here. Okay, so a and b are both real numbers and x and b are variable. Okay, so the first one they would want you to know how to do is solving and graphing linear inequalities. Okay, so for the first one, they give you the inequality that 2x is less than -2. So we're going to solve it just like we would for an equation, except keeping in mind that if you multiply or divide by a negative number, you have to flip the inequality. Okay, so first thing, we're going to divide both by a +2 to get the x by itself. So since it's a positive number, this is now x is less, we don't have to flip the sign, x is less than -1. And this is when we consider the inequality solved because we have x by itself. Okay, so graphing this though is a little different. So to graph it, you draw a number line. Yeah. And so here's where 0 would be, -1, 1, -2, 2, so on and so forth. Okay, so the way we graph this is we're going to, so x has to be less than -1. So it's here you find -1 and then you kind of shade in the number line where x can be. So now what do we do about -1? So that's where the difference between less than and less than or equals to comes in. So if it's strictly less than, like we have here, there's no equality here, you put a open bracket here. That means that you do not include -1. So if it were less than or equal to here, it would be a closed bracket. Okay. So let's move on. Do another one. So next example is 7x minus 11 is less than 2 times x minus 3. Okay. So now we have to solve this for x. So I'm going to distribute this out. So it's 7x minus 11 less than 2x minus 6. Okay, so now I'm going to put all the x's on the left side. So subtract 2x and subtract 2x and add 11 and add 11 all in one step. So this is now going to be a 5x is going to be less than, so positive 5, right? -6 plus 11. Okay, so now I'm going to divide both sides by the positive 5 so we don't have to flip the sign. So you get x is less than positive 1 now. Yeah, sorry, my cat just walked in. Alright. Okay, so now we have to draw our number line. Okay, so again we've got 0, -1, 1, 2, 3. Okay, so here again we're using an open bracket because we do not want to include one, and we kind of shade in the rest. Okay, the third example. So our third example is going to be 8 minus 3x greater than or equal to 2. Okay, so I'm going to keep all the x's on this side and put all the numbers on this side. So subtract 8 from both sides, minus 8, minus 8. Negative 3x is greater than or equal to, so 2 minus 8 is -6. Okay, so here's where we're going to have to flip the inequality because I wanted to get x by itself, and to do that you have to divide by -3. Okay, so now it's going to be x, and we're flipping it, right, because we divided by a negative number, and -6 divided by -3 is positive 2. Yeah. Okay. It's positive 2. So now, to draw our graph here, go 0, 1, 2, make this side a little longer, 3, -1, -2. Okay, so we find 2, and since it's a less than or equal to sign, we're going to use the square bracket and shade in all this. Okay. Alright, so that's how you do those inequalities. Linear inequalities. Okay, so now I'm going to switch here, and there's a word problem that I'd like to do next. So we have the textbook. So let's read this one here. So in the introduction of the text of this section, they talk about inequalities being applied to this Bermuda Triangle problem. Okay, so let's read it together. In the introduction to this section, we discussed an experiment to test the reliability of compass settings and flight by automatic plane along one edge of the Bermuda Triangle. Okay, so the plane is 150 miles along from its path from Miami to Bermuda, cruising at 300 miles per hour. Okay, when it notifies the tower that it's now set for automatic pilot. The entire trip is 1,035 miles, and we want to determine how much time we should let pass before we become concerned that the plane encountered some sort of trouble. Okay, so if you need to read that again, just rewind the video. Okay, so now, just like when we did word problems earlier in this chapter, we got to assign a variable. Okay, so we want to know that word problem asks us how much time we should let pass before we become concerned. So we're solving for a time. So we're going to say let t equal time. Okay. So now they also told us in that problem that the plane is traveling at 300 miles per hour. So 300 times t is going to be miles traveled after, at t seconds. Or, I'm sorry, we're doing hours. It's miles per hour. So at t hours. Okay. So they also told us though that the plane was already 150 miles along its path from Miami to Bermuda. So 150 plus 300t is the plane's distance from Miami. At t hours. Okay, so we also know that the distance between these two, this trip is 1,035 miles. Okay, so we want to. So if this distance, right, this is the distance from Miami. If this distance becomes bigger than or equal to the distance of the trip, then we might be a little concerned that the plane didn't make it. Okay, so 150 plus 300t greater than or equal to 1035, right? Because if this distance on the left here becomes more than the distance of the entire trip, something probably went wrong. Okay, so now it's just about solving this inequality. All right, so the first thing I would do is subtract 150 from both sides. So this is going to be 300t greater than or equal to 1035 minus 150. Okay, so that's simplifying this now as 300t greater than or equal to 885. Okay, so now to get t by itself, we're going to divide by the positive 300, right? So we don't have to flip the sign. So t is greater than or equal to 885 divided by 300 is 2.95. You can use your calculator for that one. Okay, so the answer to the question is if 2.95 hours pass, raise concern. Okay. All right. Okay. So now we're going to talk about some inequalities that might work for all, like when we solved for inequalities in the first example, our linear inequalities, they would work for a certain interval, right? So like from negative infinity, our first example is from, if you go ahead and look back at it, it's from the solution set was x is less than -1. So any number in between -1 and negative infinity would have worked. So now we're going to talk about inequalities that have like solutions that include all the real numbers, or sometimes they don't include any real numbers at all. Okay, so in this example, they want you to solve and give the solution interval, solve 7 times x plus 2 minus 20 minus 4x, okay, less than 3 times x minus 1. Okay, so now we're going to go ahead and simplify here. So we've got a 7x plus 14, right? Just distribute this, minus 20 minus 4x. Okay, now this one you also distribute, so 3x minus 3. Okay, so 7x minus 4x is 3x, and 14 minus 20 is negative 6. So this is 3x minus 6 less than 3x minus 3. Okay, so now you'll notice that these 3x's can cancel because I can subtract 3x from both sides. So you're left with negative 6 less than negative 3. So this one is a solution for all real numbers because it doesn't matter what x you're going to put in there, you're always going to get down to negative 6 is less than negative 3. So the solution set here is all real numbers. So you can do negative infinity to infinity. Okay, and the number line there would just be like 0, 1, 2, sorry, this is a negative 1. And it would just be like the whole thing, right? Okay, so now what about an example that works for no real numbers? So this is one where you're going to get inequality and it's going to come down to something that's never true. So if we get like a 2 times x plus 5 plus 3x less than 5 times x minus 1 plus 3. Okay, so whoopsies. So first I would distribute this out. Okay, so 2x plus 3x is 5x, so 5x plus 10 is less than 5x minus 2. Okay, so now again I can subtract 5x from both sides and you get 10 is less than negative 2, which is not true. So this one, solution set, this is called the empty set. So that means there are no solutions. Okay, so yeah, the number line there, you know, you don't have to draw this, but you would just fill nothing in, right? Because there are no solutions. Okay, so now we're going to talk about combining two. Combining two inequalities. Okay, so we get a 2x plus 7 is less than or equal to 1, or, this is very important, it's either or and, 3x minus 2 is less than 4 times x minus 1. Okay, so we have to solve both of these here. So for the first one, you're going to subtract 7 from both sides. So 2x is less than or equal to negative 6. And then we can divide by positive 2. So we get x is less than or equal to negative 3. Okay, so for the second one, we first distribute. So it's 3x minus 2 less than 4x minus 4. Alright, so now I would probably I'm going to do add 4 to both sides and subtract 3x. Okay, so if I add 4, subtract 3x, and subtract 3x. So you get a 2 is less than x. Okay, so now we have to, so this or comes down here too. So it's x is less than or equal to 3 or 2 is less than x. So let's draw our number line here. So if I put a 0 here, 1, 2, 3, 4, -1, -2, -3, -4. Okay, so x has got to be less than or equal to 3, so you find 3, draw your bracket here, and fill it in. X is less than or equal to 3, or x, 2 is less than x, or x is greater than 2. You find 2, and you put an open bracket because we have a strictly less than. Sorry, you guys can't see this number line right now. All right, and then we shade in the greater part. So this is what this is called a combination of two inequalities. Okay, so that's an or inequality. So now we got to talk about an and. So talking about the and inequality here, we can do an example is 2x minus 3 plus 5 is less than 9. And, rather than or here, 3 times 1 minus x minus 2 is less than or equal to 7. Okay, so now we're going to, again, solve these separately here. So this is 2x minus 6 plus 5 is less than 9. And 3 minus 3x minus 2 is less than or equal to 7. Okay, so negative 6 plus 5 is negative 1, so 2x minus 1 is less than 9, and 3 minus 2 is 1, so we have negative 3x plus 1 less than or equal to 7. Okay, so on this one I would add 1, so 2x is less than 10, and then here we can divide, so x is less than 5, and here, oh, I forgot the x, my bad. Okay, so now we subtract 1 from both sides, so we get negative 3x is less than or equal to 6. Right. Okay, so here, this one's already solved, so this one I got to divide by negative 3. So we're dividing by a negative number, which means we have to flip the inequality here. So 6 divided by negative 3 is negative 2. So here we have it. We have x has got to be less than 5, and it has to be greater than negative 2. So let's draw the number line here. So 0, we got to go all the way out to 5, 2, 3, 4, 5, and then we'll do 6 just to make it a little clearer where we're cutting it off. Here we only can go to negative 3. Alright, so first we find x is less than 5. So we find 5, draw our parenthesis, and before we scribble it in here, we know that it's kind of going to go to the left. So for the x is less than 5, we go all the way to the left. Okay? So here, now we go to x is greater than or equal to 2, and it's a less than or greater than or equal to, so we put a square bracket. Okay, and it's got to be everything to the right. So for this one, I'm gonna mark like a different type of scribble here. Okay. So notice that there's a portion where only one of them is true, here and here, and then there's a portion where they're both true. So for an and statement, they both have to be true. So this is the interval that you're looking for right here. Okay? Okay. Alright, so now, with that information in mind, we're going to talk about solving and graphing a compound inequality. Right. So a compound inequality is where you kind of have two inequalities in the same line here. So an example would be 2x negative 5 is less than 2x plus 3, which is also less than or equal to 9. So this is a compound inequality. Okay, and then this example is to solve for both, solve it and graph it. Okay, so we need to get x kind of in the middle by itself here. All right, so the way you can do that is, this works kind of like an inequality. So to get this 3 out of here, you subtract 3 from not both sides, but all 3 sides, since it's compound here. So this now becomes negative 8 is less than or equal to 2x. I'm sorry, that's not a less than or equal to, that's a less than. Less than 2x, which is less than or equal to positive 6. So now we divide by positive 2, and we get negative 4 is less than x, which is less than or equal to 3. Okay, so now over here on our graph, 0, 1, 2, 3, and 4, negative 1, negative 2, negative 3, negative 4, and just for good measure, I'm going to write this one, 5. Okay, so we find negative 4. Right, so we find negative 4, and this is saying that x is greater than negative 4, or negative 4 is less than x. So we shade everything to the right, and then we find 3, shade everything in between. Right, okay. Okay, so our solution set, I should have been writing this too, but it's just negative 4 to 3 and then close bracket. So you can do that for all the examples that we've done so far. Okay, so let's move on. So we have another example. Okay, so this one is a little different. So if the problem is stated this way: if negative 2 is less than x, which is also less than 5, find real numbers so that a is less than 3x minus 1, which is less than b. Okay, so we're given this inequality, and we're asked to find out what a and b are going to be. Okay, so you start with the given inequality. So we have negative 2x, whoopsies, negative 2 is less than x, which is less than 5. Okay, so now we're going to basically take this starting inequality and kind of make it look like this. So we need to make x look like 3x minus 1. So to do that, I'm going to multiply all 3 sides by 3. Okay, so we get a negative 6 less than 3x less than 15. Okay, and so now I just need a minus 1, so subtract 1 from all 3, and we get negative 7 is less than 3x, which is less than 14. So a would equal negative 7. Oopsies, and I forgot to subtract 1 off the middle here. Right? 3x minus 1, less than 14. A would be negative 7, and b would be 14. Okay, so this one you have a sort of application problem to it as well. So there's another example here in the book that I'd like to read here. So let's say you're going on a vacation. You were going to go on a vacation to London. So the weather in London is predicted to range between 10 degrees Celsius and 20 degrees Celsius. During the 3-week period, you'll be working there. Okay, so it's not a vacation, you're working there. To decide what kind of clothes to take, you want to convert the temperature range to Fahrenheit temperatures. Okay, so they give you the formula to convert Celsius or Fahrenheit to, or Celsius to Fahrenheit. You input your Celsius temperatures here, and you get your Fahrenheit temperatures here. So if basically this one, so if we want to figure out the range of temperatures in Fahrenheit, what of our given degrees Celsius, it's kind of like this example we just talked about. Instead, though, it's going to be your given inequality. Whoa, that is a bad G. Sorry. Given inequality is, so it's 10 less than C, sorry, less than or equal to C, less than or equal to 20, because it says in the problem, the very first line, the weather in London is predicted to be in between 10 degrees Celsius and 20 degrees Celsius. Okay. So now they're now asking you what to convert this to Fahrenheit. So just like before, we're going to take our F is equal to 9 over 5 Celsius plus 32. So we're going to start with this given one, and we're going to make it look like this for Fahrenheit. So we have 10 is less than or equal to C, which is less than or equal to 20. So now to get it to look like 9/5 C plus 32, I need to multiply all three by 9 over 5. Okay, so 90 divided by 5 is 18. So 9/5 times 9 times 10 is 90, and then you divide it by 5. 90 divided by 5 is 18. So 18 is less than or equal to 9 over 5 times C, which is less than or equal to 36. 20 times 9, 20 times 9 would be 180, and then if you divide that by 5, you get 36. Okay, so now we've got a 9/5 C here, but we want a 9/5 C plus 32. So we're going to add 32 to all three sides, plus 32. So 32 plus 18, that's 50. And this is 9 over 5 Celsius plus 32, which is less than or equal to 36 plus 32, which is going to be 68. Excuse me. Okay, so now we can take, this is Fahrenheit, so we can substitute an F in for that. So we've solved the problem. So if you don't know what 10 degrees and 20 degrees Celsius are, it's 50 degrees Fahrenheit and 68 degrees Fahrenheit. So that's what the temperature would be in London on your working trip. Okay, so getting to the end of the section here. So that's good. So now we're going to move on to another type of problem that we might see. Okay, so the next example is solve x squared plus, so this is now not linear anymore, right? All of the ones that we've been working before are linear, but this one is not because we've got a quadratic term here, this x squared, okay? So we never had to deal with like x to a different power than 1 until now. Okay, so the good thing though is this uses some skills that we've already learned. You first need to, kind of like what we did when we were factoring, is you need to move all of the terms over to one side. So I'm going to subtract 5x from both sides and subtract 6. So now we have x squared. 4x minus 5x is a minus x and then a minus 6. which is greater than or equal to 0. Okay. So now we're going to factor this side. So we've got two numbers that multiply to -6 but add to -1. So we're going to do x minus 3 and x plus 2. Okay, so we factored the left side. Notice we haven't divided or multiplied by any negative numbers, so our inequality stays the same. Okay, so what does this mean though? We haven't really solved it for x, right? Usually we solve it and then we can draw our number line. So here when you have more than a linear, when it's not linear, it's quadratic or even more degrees, and you factor it down like this, you can use this method called the book calls it test point method. Test point method. Okay, so you basically you treat this as an equality for a second. So solve x minus 3 is equal to 0 and x plus 2 is equal to 0. So this one's going to be x is equal to 3, and this one's going to be x is equal to -2. Okay, so the degree, this is a degree 2 inequality, right? Because we have the highest exponent is 2. So you're going to have at most, 2 to solve for, right? So if this were a degree 3, you'd have maybe 3 or less. So then you have to draw your number line after you've solved these 0 points here, and we're going to mark those on our number line. So if this is 0, 1, 2, 3, 4, -1, -2, -3, and -4. Okay, so here's 3. And here's -2. So we marked our 2 zeros. Okay, this is where right, this is the inequality would be, if I put 0 in here, you get 0 is greater than or equal to 6. So that's not quite right, but it's just where your inequality is, where you kind of treat this as an equality. You put an equal sign here, and then you solve for these 2 zeros to find these 2 points. Then, so once you have these 2 points, you've got now 3 intervals. You have -infinity to -2, and right, that's one of the intervals. You've got -2 to 3, and you've got 3 to infinity. So depending on how many zeros you have will affect how many intervals you have here. Okay, so in this case we have 2 zeros, so there's 3 intervals. But if we had, for example, 3 zeros, there would be 4 intervals. Okay, so on and so forth. It's always one more interval than the amount of zeros you have. So the test point name comes in now is you want to test a point in each of these intervals and see what your sign is. Okay, so basically we're taking, so if we take, you find test points. So, and these are the convenient, you pick convenient points here. So for this interval, you can pick anything that's in this interval, right? Notice that we excluded the -2, because if we pick -2, we just get a 0. Okay, so we're trying to see what sign this multiplication gives depending on the x we choose. Okay, so if it's right, if this number times this number is positive, then our equality works. But if this number times this number is negative, if we get a negative number for the test value, then that's not true, right? So that's what we're trying to see here. Right, okay, so if I pick, for this interval, I'm going to pick -3, interval 1. Oh, that's bad. Okay. So for the next interval, I'm going to pick 0 because usually 0 is like an easy number to plug into equations, right? And for the final interval, you can choose 4. Right, so we've got, you can notice you could have chosen, for the first interval, you could have also chosen like -50. Anything that's in this interval will give you the same sign. For this interval, you could have chosen 1, -1, whatever is in here, and same for this one. But I just chose these. Okay, so I usually try to choose like the smaller numbers, small whole numbers, and if 0 is an option, I always try and choose 0. It's because I said it's easy to plug in. So now we're going to test them. The sign. So test the sign, which means positive or negative, of x minus 3 times x plus 2. Okay, so if I plug a -3 in here, I get -3 minus 3 times -3 plus 2. Okay, so that's going to be -6 times 1. So that's -6 or negative. I messed up. This is a -1. -3 plus 2 is not +1, it's -1. So -6 times -1, though, is positive. So we have positive. So the first interval, we can put a little plus sign right here since we have a positive. Okay, what about 0? So if I do 0, I get 0 minus 3 times 0 plus 2, which is equal to -3 times 2, which is equal to, that's actually -6. So we have a negative. So we can put a little negative sign right there. Oh, sorry. There we go. Okay, what about the last interval? So if I do 4 minus 3 times 4 plus 2, that's equal to 1 times 6, which is equal to 6, so it's positive. Positive right here. Okay, so like I said, so this one is positive, so that means, you know, when we plugged in -3 here, we got a positive number on the left-hand side, which is what we want. That satisfies the interval. So we're going to fill this interval in. And because we're doing a square bracket, because if we plug in -2 here, we get a 0 on this side, right? Like -2 plus 2 is 0. So it's saying 0 is greater than or equal to 0, which is true. So that's why we're including the value -2. So we're going to shade all this in. Okay, but in between here, our test point said that we get a negative number, and in fact, if one of these test points in here says you get a negative number, then all of these numbers are going to be negative in this multiplication. So that would be like saying this left-hand side, a negative number is greater than or equal to 0, which we know is not true. So we're not going to shade in any of that second interval. Okay, so now we're going to talk about, so this same reasoning here, if we plug 3 in here, we get 3 minus 3, 0 on this side, and 0 is greater than 0. So we're now going to shade everything over here because we have a positive test sign. Okay, so that's kind of the point, test point method. Okay. So now, finally, the last one I want to talk about is solving a rational inequality. Okay, so like if something involved with a fraction. Okay, so let's solve x squared plus 2x minus 15 divided by x minus 1 greater than or equal to 3. Okay, so in this one we're actually gonna, instead of finding the common denominator right off the bat, we're gonna subtract, get it so this side is 0. Okay, so we're gonna subtract 3 from both sides. So we get x squared plus 2x minus 15 divided by x minus 1 minus 3 is greater than or equal to 0. now is where we find the common denominator. So to do that, I'm going to multiply this term here by x minus 1 divided by x minus 1. Right, I'm just multiplying by 1 there. So again, you're just finding the common denominator, least common denominator actually, plus 2x minus 15 over x minus 1, minus 3 times x minus 1 over x minus 1 is greater than or equal to 0. Okay. So now we've got the same denominator, so we can add these two fractions together. So we get x squared plus 2x minus 15 minus 3 times x minus 1. And then, again, this is all now just one fraction. Okay. So now we're going to simplify this, the numerator here. So this is x squared plus 2x minus 15 minus 3x, and then minus 3 times minus 1 is positive 3. Divided by x minus 1 is greater than or equal to 0. That looks kind of like a 6. So, oops. So 0. Okay. So again, with the simplification, we've got combining some like terms here. So this 2x and negative 3x is a negative x, and negative 15 plus 3 is negative 12. So we get x squared minus x minus 12 is less than x, or over x minus 1 is greater than or equal to 0. Alrighty. So now we're going to take the numerator here and factor it. So I need two numbers that multiply to negative 12 but add up to negative 1. So we can use x minus 4 and x plus 3. So as you can see, we're getting a lot of practice with factoring those quadratics, right, that have a 1 out in the as a first term. So x minus 1 greater than or equal to 0. Okay. So now, just like the test point method, we're going to use the test point method here again. So you want to solve each of these. If you have a fraction equal to 0, it's when the numerator is equal to 0. It doesn't really matter what the denominator. You can't really. Nothing you put in the denominator will make a fraction 0, right? It doesn't matter what you're dividing by. The only thing you have to watch out for is if you're dividing by 0. Okay, so it turns out you want to set the numerator and the denominator equal to 0 and solve for them in rational inequalities. So we get a x minus 4 equal to 0, x plus 3 equal to 0, right? So that comes from setting this whole numerator equal to 0, and then when you have a number times another number equal to 0, then either that one number is 0 or the other number is 0. Okay, so then finally when you set the denominator equal to 0, it's just as simple as setting the denominator equal to 0. Okay, so now we solve for all these. So x would be 4 on this one, x would be negative 3, and for this one, x is equal to 1. Okay, so those are our those are our interval points where we need to, break up our number line. Okay, so let's continue. So those are the numbers that we need to see. So drawing this number line here, we get 0, 1, 2, 3, 4, 5. Negative 1, negative 2, negative 3, negative 4, negative 5. So let's mark all of our points here. There's 4, there's negative 3. And what we're going to do for this one, this is a denominator. So this one, when x is equal to 1, you get 1 minus 1 in the denominator, so you're actually dividing by 0. So that one we're going to mark a little differently. That's going to be a circle. So that means it's undefined at 1. Okay. So we still use these points to make our intervals, though. So this interval is negative infinity to negative 3. So we have 3 points this time, which means we're going to have 4 intervals. So the next interval is negative 3 to 1. Then we have 1 to 4 and 4 to infinity. Okay. All right, so we're going to come up with test values. So a decent test value for this one is negative 4. 0 is available in this one, so we'll use that. This one you can use, I would probably do 2, and then this one, let's just do 5. It's the lowest whole number. Okay, so now I'm going to test, remember up on the previous page I was writing on, we had x plus 3 times x minus 4, or maybe I flipped the order of those around, doesn't matter though, is greater than or equal to 0. So we need to test our test points and determine, if we put a point in here, if it's positive it works, if it's negative it's not good, or if it's 0 it also works. Okay, so our test point for negative 4, we get negative 4 plus 3, negative 4 minus 4, and negative 4 minus 1. Okay, so also you don't really need to solve for what this number is. You just really need to know if it's positive or negative. Okay, so here minus 4 plus 3. Well, instead of writing negative 1, let's just write the sign. So it's a negative number times negative 4 minus 4 is negative 8. So here, I'll write the numbers in for now. Negative 1 times negative 8 over negative 5. Okay, so think about this. So we don't really need to compute what this number is, even though it's just positive 8 over 5. We just need to know, negative 8 over 5. We just need to know if it's positive or negative, right? So we have 3 negative signs. So 3 negative signs is the same thing as just a negative number, some negative number. Okay, so this one up here by our first interval, I'm going to put a little minus sign. So that means that this number is negative in this interval, so it doesn't work. Okay, continuing on here, we get 0 plus 3 times 0 minus 4 divided by 0 minus 1. So this one is a positive number times a negative number divided by a negative number. So we have two negatives. A negative divided by a negative number is positive, just like a negative number divided by a negative number is positive for the same reasoning as a negative number times a negative number is positive. 2 negatives make a positive. 3 negatives make a negative. Okay, so now I can come back here and put a little plus sign right there. Alright, so now the last two, we get 2 plus 3 times 2 minus 4 over 2 minus 1. So this one is a positive times a negative over a positive. So this one has one negative sign in it, so it's negative. Sorry, I'm not doing a great job of moving my paper. Okay, so again, positive, negative, positive. Alright, so we'll put a little negative sign right there. And I guess we don't really need this page anymore. Alright, okay, so finally we've got our last test value, so we got a 5 plus 3 times 5 minus 4 divided by 5 minus 1. So this is a positive number times another positive number divided by a positive number. So there's no negatives, making this one positive. So we can put a positive up here. And now we can fill in our number line. Right, so we're looking for, we tested values into this inequality. And so this one right here, the first interval is negative. So that means they're saying in the first interval, if your x is in this interval here, you're going to get a negative number on this side, which means that you'd have a negative number being greater than or equal to 0, which is incorrect. So we are going to exclude the first one. And for the same reasoning, we're also going to exclude the third interval. But the second and the fourth interval are fine. So we're going to actually include 3, right? Because if we put 3 in here, it's negative 3 plus 3, which is 0. So this becomes a 0, and it's 0 divided by 2, I believe. So which is still 0 is greater than or equal to 0. So if this were a just strictly greater sign, this would be a regular bracket here. But since it's greater than or equal to, we're going to include our 0 points. Okay, we don't include our undefined point because it's just undefined. So we are going to color or number this, shade this here, and then similarly shade that, and include the 4. You can also just not do these brackets here and just write a circle there. Okay, so the way that you could enter this on the computer, I think, is so our solution interval is negative 3 to 1, but we're excluding 1, so we draw this around the 1 and the closed bracket around the 3, and then you can write this upside down U is the mathematical symbol for OR. So OR, yeah, sorry, KitKat. Or 1 to 4. Okay. Oh, I'm sorry. So that's not correct. It's 1 to 4 is not the correct interval here, and I actually messed up on this number line. So this should not be shaded in, right? It's because this third interval is excluded. So we're actually trying to go this way. There we go. So yeah, I had that messed up. Okay, so back to our solution set though. So then you want to include 4 and then go all the way to infinity. But you can never get to infinity, so that's why you always draw you do not include infinity because you can never technically get there. Yeah. Okay. All right, so that's the end of today's lesson. Sorry about that mistake there. I should have caught that, but hopefully you watched till the end and saw me fix it. And again, so office hours will be at 3, Monday, Tuesday, Wednesday, Thursday, and I guess I'll see you tomorrow.